Here's one of the first things to consider when getting a wood stove. Though of course any form of automatic heat I think is actually more dangerous than a well-watched wood stove. The previous owner was even more paranoid than average, but the fire department recommends that a supply of water is even more effective than a fire extinguisher in eliminating a wood stove blaze. This is my stove that I've spent about a year modifying. It's originally a straight-through combustion chamber design. And you can see I've added a copper heat transfer coil to the nearby furnace. It's a double spiral with a splice in the middle, so it makes it easier to weight it down. I have a little backup monitoring of the temperature. The bricks cut down the infrared radiation so that we can use equipment right nearby. The drill press is right there. And also that the control equipment stays cooler. This is what keeps it running efficiently. Is a PID controller on the right for the basic control of where the air is going, and monitor the flue temperature with that indicator. You can see it's at 250 degrees now. And we also, with an automatic cutout that rings an alarm, and we have a switch to turn the alarm off if you're working there. And then another high temperature meter relay to again trip the alarm if the temperature of the secondary combustion zone gets too high. It has lots of spare equipment, a way to reduce the voltage on the circulator with a variable transformer so that it uses less electricity, and spare thermocouples of multiple types. The main thermocouple that reads the temperature upstairs is there, and then two others for the automatic control and the high limit go in on the right hand side there. This used to have a bimetallic element controlling the airflow mostly on or off, and resulting in lots of smoke production. I modified that so that the airflow is now under manual control, and the servo motor here is able to pull on a little wire that goes inside to modify whether the incoming air is directed to the base of the fire or upwards to the secondary combustion zone. Here's some of the interior. There's the deflector. The damper is invisible there inside of it that allows the air to either go upwards or downwards from that point. The original design had the fire going out the back of the combustion chamber. Now, however, it goes right overhead into a secondary combustion chamber that's all fully insulated. You can see the white material on the walls is insulation, and that there's about 3 inches of lost space because of this. 1 inch of that is the insulation, and then there's 1.25 inches of airspace behind it. This will get out of control if I leave the door open too long. This is all ceramic fiberboard like the space shuttle uses, except much stronger and more durable. It is now attempting to compensate for my allowing so much air in. It is cutting off the air to the bottom of the fire and actually pulling open the main air damper further to dilute all that secondary combustion zone air with fresh air, and hence reduce its temperature. So now if I close the total airflow, you'll notice nothing moves. That's because the servo motor, by that little ball chain that you see, is pulling open that. And the temperatures, you can it's reached 1300 degrees Fahrenheit and is now dropping again because it's a moderately fast response system to these changes. I use over there is a 24 volt furnace circuit transformer with class 2 outputs, so that I can, that's in turn what the motor runs off of, so that all my wiring can legally be this thermostat wire or bell wire type equipment. And similarly, the alarm bell is also 24 volts, although it needs direct current instead of alternating current. So there's a rectifier bridge hidden over there. The smoke pass in this stove is hard to see from the outside. As I showed you before, the secondary combustion zone is up there, and the high temperature gases finish burning at this level of the stove, at the top of the door, and then they reach the loading damper, which is right in front of the flue pipe. So when that loading damper is open, the gases are going right up the flue pipe. When it's closed, the gases go into this space just below the top of the stove, and then go forward to about there, and then they go down the side of the wood stove and along the bottom of it, and then they collect together at the back. It's too dim back there, I think, to see much. They and then they go up the stack. So by then they've cooled off to about 300 degrees Fahrenheit, which doesn't produce any creosote in this stove because all the creosote has been burned. And you can verify that this thermometer gives about the same reading if the focus would work a little better. It's saying perhaps 250 degrees at that point, whereas the thermocouple is right in the very top there where it's entering the chimney. This is an indoor chimney, so the gases are still cooler by the time they go outside. When we clean the chimney every fall, we get only a couple quarts of powdery residue out of both the chimney and that smoke pipe. The clean out, we have to move these bricks in order to get out the clean out door, which is right behind them. This is the view from the furnace direction, and these are the tubes I added. and the additional circulator pump, each with isolation valves, and for the whole loop, and a pressure relief valve, an additional pressure relief valve for this part of the system. The an additional high limit thermostat is actually glued on down there, just right to the brass with some epoxy. Afraid it's a little bit in the shade there. So this here's another portion of the system that I modified. It looks like a normal Honeywell thermostat. However, this one has 2 sensing bulbs for heating and 2 sensing bulbs for cooling. This is called a 2-stage thermostat for 2-stage heating and cooling. But I use the first closing stage to activate the circulator pumps, and then the second stage brings on the oil burner. So in between there, it's distributing heat from the wood stove without adding any carbon to the atmosphere. This is a additional thermostat that we added and put the sensing bulb in this cold corner of the house up on the radiator, the pipe to the radiator, in order to keep that from freezing, because this the warm air from the wood stove was able to keep the house warm enough in below freezing weather that we did have this junction freeze up. So instead, this thermostat turns on the circulator, an additional contact in parallel with that 2-stage thermostat up. This is the wiring for the thermostats and the zone valves. It could, of course, be in a box as terminal strips, but none of that is required by electrical code. Those labels on the wires, of course, can keep your house from freezing when you've forgotten which wire does which. So those are very important. We have a 2-zone system here, and it's for upstairs and downstairs. This meter is right beside the kitchen in the home office and displays the current temperature of the secondary combustion chamber and the wood stove, so we know when to go down and fill it, and also keep track of it's behaving well. There's another smaller meter in the family room near the TV also. I wanted to show you some of the things I've discovered about loading wood stoves. First of all, long sleeves are needed. Insulating gloves. These gloves are flammable. Dipping them in water helps extend their life. Having a bucket of water handy close by helps reduce burns, and or you're able to put out fires. Number 1, of course, open the loading damper. Number 2, open the door. I like to always remove ashes every time. Some stoves have a much larger area for ashes than what I've done. The ashes in mine actually fuse together because of the high temperatures. I don't take any charcoal out except for a few scraps. It does help sequester carbon if you do this, but you lose fuel. Always cover the ashes tightly with a metal lid if you don't want to get carbon monoxide poisoning. The next step is to make sure all the charcoal is out to the front. The charcoal cannot on this type of stove that has no grate, the charcoal cannot burn in the back of the stove because it needs the incoming air. If you leave it about in the middle, it performs some of the functions that a grate would perform of lifting the wood up. I find that about 3 or 4 inches of charcoal in there assures a moderately rapid starting to the fire. If it's a little slow, some of the debris that falls off the firewood will help speed it up. Also, holding the door partially closed gives a little more air velocity. A little bit of paper. Generally gets it going. I usually, during the main part of the heating season, we only use 1 or 2 matches per month. And then close the loading damper once it's going. Open the air all the way. And then you can leave it in this state, but don't go away for a minute or 2 to get a roaring fire. And then come back in perhaps 15 minutes and set the airflow to the desired setting. One other thing that you always need with firewood, of course, is access to more firewood from outside. This is our newly renovated door. And this is how we keep the door from getting smashed like previously by the wood coming down. The original owner removed the stairs and made them replaceable. There's room here for about half a cord of wood, which lasts us about 2 weeks. So there's about a quarter of a cord left in here. And then it holds about 8 wheelbarrow fulls. Large wheelbarrow is what it takes for half a cord. And we just dump it in from the wood pile about 100 feet away and carry it and run it over here and dump it in. So it eliminates a little bit of the wood handling. I've counted that I pick up each piece of wood 7 times. So that's a significant amount of exercise just in moving it. And that doesn't count splitting it and cutting it. The wood frames on the sides are held on with Gorilla Glue only. And that seems to be quite adequate. And much simpler than trying to drill holes and use mechanical anchors. We carry the wood about 25 feet over. right next to where we keep another fire extinguisher, water, and a spritzer with water for cooling it off. And sorted by size, these are the large ones. You'll notice that since these are custom split, two of those big rectangular ones quite neatly fill up the stove for all night burning. So these I put in at night, hopefully when the stove is still nice and hot. And then these we use in the day. So this is about a day's worth of wood you see here, 24 hours. Keeps the house up to 72 degrees when it's above 20 outside, or 25, somewhere in there.